Good morning, myself Ashagila Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about a topic, subset of sum problem. So what is the outcome of learning this particular topic is, on successful completion of this module, the student should be able to illustrate the subset of sum problem using backtracking approach. So what are the things we are going to see in this particular video is, we are going to see the introduction, what is subset of sum problem and what is backtracking approach, the algorithm for the subset of sum problem, and the time and space complexity of that. So first we are going to see the introduction. So to solve the subset of sum problem, we are going to use a backtracking approach. So what is backtracking approach? In a backtracking approach, we'll try a particular possible way. If there is no solution in the particular way, means we have to backtrack to the previous step and we have to try the next way. That is what we call it as a backtracking approach. So, what is subset of sum problem? Subset of sum is a mathematical problem that involves finding a subset of a given number whose sum matches with the target value. For example, if we have the set of numbers 2, 4, 6 and 8 and the target value is 10, means what is the solution? The solution is 2 and 8. That is, if you add 2 plus 8, you will get 10. Or we can say it is 4 and 6. So, when you add 4 plus 6 also, you will get 10. So, you can have more than one solution. So this problem can be solved by using backtracking approach. So we are going to draw a state space tree for that. So we'll try a particular branch. If there is no solution in the branch, means we have to backtrack to the previous position and we have to try the next branch. So we know that what is backtracking approach. In a backtracking approach, to solve this problem, we are going to use a tree called the state space tree, where in this tree we are going to try a particular path. If there is no solution in the path, means move to the previous step and we have to try the next way. So in a state space tree, we can have more than one solution. So next we are going to see the algorithm for the subset of sum problem. So the backtracking approach is a recursive algorithm that solves a subset of sum problem by exploring all the possible solutions. So it starts with the empty set and adds the element one by one until the sum of the set is equal to the target sum value. So if it exceeds, means we have to move to the previous step and we have to try the next solution. So this algorithm backtracks when there is no solution in a particular branch. Next we are going to see the pseudocode for the backtracking approach. First is check if the current sum is equal to the target sum. If yes, means you have to return true. Second step, if the current sum exceeds the target sum, means if there is no more element to be considered, means you have to return false. Third step is try to add the next element to the sum and recursively check if it leads to the solution. Fourth step is, if adding the next element does not lead to the solution, means remove it from the sum and try the next element. Fifth step is, if none of the element is lead to the solution, means backtrack to the previous step and try the different element. So this is what we call it as the pseudocode for the backtracking approach. So next we are going to see what is the time and space complexity of this. So the time and space complexity of the subset of sum problem by using backtrack approach is always high. See example, for the time complexity is big O of 2 power n. Similarly, the space complexity of the algorithm is also quite high. So because we need to store all the possible subsets of the given in order to find out the subset which decides or which produces the correct sum. So that's why the time complexity and space complexity is high. Thank you.